This conference will now be recorded.
So, as far as what I have discussed here, so basically we discussed about some network security group and then some network security rules as well, and then we have implemented some this network security group practically as well, right? So, and then we discussed a small concept on yesterday. So that is nothing but importance of priority in networking. I mean, if you observe while creating some virtual machine, so once this creation is done, I mean creation of virtual machine is done, we're having some option called as a networking. So basically in that respect to networking, we are trying to add some inbound port roles. If a particular virtual machine want to allow some putty software or maybe some DP or maybe some HTTP or HTTPS. So if you want to allow some ports or some softwares in that respective virtual machine, need to configure this inbound port rule, or we can say that we can configure some security rules basically, right? So there we're having option called as a this priority or inbound portal or security role. So while creating these things, right? So we're having a one field called as a priority. So that thing we discussed here. So and we have created some practically as well. So we have created some resource group, virtual network, and sub network, and finally we have created some virtual machine. So these all these things we have done, and then we discussed about and we have added some rules, and basically we have added some HTTP rule and with action as a allow and, and a deny as well. But if you observe this action deny, we have given some priority value as 108. So and Linux machine is also giving importance only with the priority is having some less number is having a more importance when compared to priority with higher value, right? So that thing we have concluded uh, while implementing practically as well. So finally, we can conclude that the priority number with the less value will have more importance when compared with priority number with high value. So this is the conclusion. So which are discussed on yesterday, right? So any doubts in this? Any of you? Is this things is fine? Any doubts? So now today we're going to discuss about a new concept, that is what is the reason to go for.
Shiva,
Yes.
Shiva, in login, it is showing some credits, 11,500 credits. Can we do certification with that credits, or else it's only useful for this training practice?
Only for practice, that's it.
Okay,
So till that credits is available, you can use this free trial, but it is only for 1 month. So within 1 month, let us assume after 1 month that anyway that credits is not available. So before 1 month, even if you are utilizing or not utilizing, that credits is going to be, I mean, that credits itself will not be available simply.
okay, sure.
Okay. So first of all, what is the reason to go for VnetPeering? Okay. So or what is the necessity to go for VnetPeering? Okay. So here, or if you want to achieve this VnetPeering concept anyway, so we will know that so what is the reason to go for VnetPeering or what is the necessity to go for VnetPeering. So anyway you can know basically, so whenever while discussing the respective concept, and if you want to implement this concept practically, so what are the things required? So these things just we're discussing now basically. Okay. So first thing is, till now we have created only one resource group, right? So we need to create two resource groups. Two resource groups. That is, one is maybe some source RG, So it maybe belongs to some East US. And one more thing is destination origin. It maybe belongs to West US. This is the first step. So then create source hyphen vnet and source hyphen subnet one and source hyphen subnet two in the source RG source group. Okay. So within this resource group, what are the resource group which are created? That is nothing but source RG. So within that, we need to create one virtual network. So it can be any name. So just have taken some name as a source hyphen vnet, right? And within that VNet, I'm trying to create two subnets. One is source hyphen subnet one, and one more thing is source hyphen subnet two. Okay, in the source RG resource group. So then deploy or create Linux machine one, Linux machine two, in the respect to source hyphen subnet one and source hyphen subnet. Okay. Means whenever if you're trying to create some virtual machines, right? Let us assume if you're trying to create some Linux machine one. So there we have one option called as the networking. So where you can select the respective virtual network and the respective subnet as well, right? So whenever if you're going with some Linux machine one, so select virtual network name as source hyphen vnet and followed by some subnet as source hyphen subnet one. Whenever if you're going with some Linux machine two, source hyphen vnet and source hyphen subnet two. Okay, that is the main. Create destination hyphen vnet and destination hyphen subnet 3 in the destination archive. Create destination hyphen vnet and destination hyphen subnet 3 in the destination archive resource group. Deploy Linux machine 3 in destination archive or destination hyphen subnet. Okay, so these things we need to do practically. Okay, so let us represent the same things in diagram so that it is easy for us. Source RG So Sarji, I can net one. This is net two, and inside of this, we are trying to create some line extension, right? Let's go. So line extension one, line extension. Okay, this is the same thing. So which we represented here. Let's go. These statements just are represented in diagram. Okay. So here we're having only one subnet, right? Let's go. This is destination object, right? This is destination object. This is subnet. So within this, we are able to create some line extension. So this is the thing, basically. Okay. So now here, so what we need to achieve. So once if this concept is implemented practically, right? So we need to cross check that whether Linux machine. So whether this Linux machine one is communicating with Linux machine three or not, or Linux machine three is communicating with Linux machine one or not, or Linux machine two is communicating with Linux machine three or not, and even Linux machine three is communicating with Linux machine two or not, or otherwise. So Linux machine one is communicating with Linux machine two or not. So Linux machine one is communicating with Linux machine two or not. So these things we need to cross check basically. Once if we implement these things in Azure Cloud account. Okay. So these are the things which we need to cross check. So once if we created some this Linux machine in the different resource group, followed by some different virtual networks and sub networks as well. So just you need to cross check. So whether these individual machines is communicating with each other or not. So just we need to cross check with all these things basically. Okay. So let us implement these things in practically. So just log into portal.azure.com. Provide your login credentials. So what is the first one? Need to create some resource groups, right? So just try to create. So source RG, right? Each to yes. So click on next tag. If you want, you can provide the tags. Next review and create. Finally click on create. So I want to create a one more resource group with name as destination RG in West US, right? Basically. Next tags, next review and create. Click on create. So it is created. So then I need to create some VNet basically, virtual network. Click on create. So resource group is source RG. Here source hyphen VNet. Next IP address dot 11.0.0 hash. Okay. So next security. Sorry, we need to create some subnet as well, right? So what is the subnet name? Source hyphen subnet dot 11.1.0. So one way is you can create a one more subnet if you want here. Otherwise, once this virtual network is, once this virtual network is created, so then also you can create a one more subnet. Okay, any of these ways you can create this. So next security, next tags, next you can create. Finally, click on create. So next, so it is created, right? So just click on this VNet and here go to subnets. Here you can try to add a one more subnet. Okay, so maybe some source hyphen net to on here. So now if you observe these things we have done, right? Basically, we created source hyphen VNet, and within this respective virtual network, we have created two subnets. One is source hyphen subnet one, source hyphen subnet two, which falls under source RG resource group. Okay. So then we need to create a two virtual machines for these two subnets. Okay. Let us do that. So let me create some virtual machine as well. So source RG, maybe some annex machine one. Okay. So location is east US. I'm going with passport. So these things you know, right? So selecting image and size. I'm giving some username and password. Public inbound bonds at this point of name. So after creating, we can add it. So next disk, select standard SSD, next networking, next management. So click on disable, next advanced, next tags, next event create. Finally click on create. So it is created. So now go to this virtual machines. Click on this Linux machine one. Try to add this inbound port rules. Click on add inbound port rule. So just I'm giving some star. So allow all the ports. Click on add. So now we need to create a one more virtual machine as well. Right? That is nothing but Linux machine 2. Click on create. So resource group is source RG. Linux machine 2. Go with password. None. Next disk. Select standard SSD. Next networking. So here you need to select source hyphen subnet 2. Okay. But which network is same virtual network. Okay. So next management. Click on disable. Next advanced. Next tags. Next review and create. Finally click on create. So it is created, right? So try to add this in one portal. So if you observe these things we have done. Step 3 is done, right? So now we need to implement some step 4, that is we need to create virtual network. On create and select the resource group name as destination RG, destination VNet, right? Location is, sorry, region is West US. Next, IP address, add subnet, destination sub, add, next security, next tax, next we can create, finally on create. So it is created, right? Destination VNet. So now we need to create a one more virtual machine, that is Linux machine 3 in destination VNet basically. So set the resource group as a destination RG. So which is Linux machine 3. Go with password, on none, next is go channel SSD, next networking. So here destination VNet and destination sub. Next management, on disable, next advanced, next tags, next we can create, finally click on create. it is created, right? So try to add some inbound payload here, and extension 3, right? Okay, so it is created. Finally, we have created 3 Linux machines, right? Based upon this respect to diagram. So now what we need to do? So just we need to check this internal communication between these respect to virtual machines, right? So after creation of principal resource groups, virtual networks, subnets, and virtual machines. So here we are going with some Linux, right? We need to cross check communication between these. Okay, so and one more thing is, if you observe in our previous classes, right? So we had discussed it to we had discussed some concept of what we call public IP and private IP, right? What is this public IP? To connect internet to virtual machines, right? Or virtual machine. And one more thing is discussed about private IP. So internal communication between virtual machines. So basically, this thing we have seen already so many of times, right? So once if we created some virtual machine, if we want to utilize or if we want to access, right? So based upon the respective virtual machine, we are going with the respective software. So if it is a Linux, means we're going with some putty, right? If it is what we call, if it is a Windows virtual machine, means we're going with some RDP basically, right? So these things we discussed public IP. Now if you observe this private IP is nothing but a internal communication between the virtual machines. Okay, if you want to communicate or if you want to check the whether the communication is happening or not between these two virtual machines, right? We can go with this private IP basically. Okay, so now as I mentioned you in this diagram, if you observe this REST diagram, right? So which IP address I need to go with, whether it is a public IP or private IP, if you want to check the communication between these respect to virtual machines. Did you got my question? If I want to check the internal communication between this respect to virtual machines, which IP address I need to use? Is it public IP or private IP? Hello,
Private IP.
private IP. Yes. So first of all, let me log into this virtual machine 1. So if you want to able to log in, basically we're using some public IP address. It is a Linux. We are going with some putty and we are copy pasting and we are providing some username and password. So if you observe here at the top, it is a Linux machine 1, right? Clear here. So if you want to access some Linux machine 2, so same thing, go with putty. Sorry. Here now it is Linux machine 2, right? So if you observe this diagram, first we're going to check the internal communication between this respect to Linux machines. I mean Linux machine 1 with Linux machine 2, Linux machine 2 with Linux machine 1. So here we need to use some, as you mentioned it, we need to go with some private IP address, right? Basically. So here we're having some 10.11.1.4. This is the private IP address of Linux machine 1. So whether it is communicating with Linux machine 2 or not, so just ping this IP address in Linux machine 2. So this is Linux machine 1 and this is Linux machine 2, right? So ping 10.11.1.4. So if you observe, it is communicating. I mean Linux 1 machine is communicating with Linux machine 2. Now if you want to cross check Linux machine 2 is communicating with the Linux machine 1 not, so just you need to type some ping with respect to private IP address of Linux machine 2. So that is 10.11.0.4, right? Just click on enter. So it is also communicating. I mean Linux machine 1 is communicating with Linux machine 2, Linux machine 2 is communicating with Linux machine 1, right? So is it clear till now, all of you? Any doubts till now, any of you? So we can conclude that Linux machine 1 is communicating with Linux machine 2, Linux machine 2 is communicating with Linux machine 1, right? Okay. So now what we are going to do is, so just type Control C, is also Control C. So now try to log in with Linux machine 3. Go with putty on open on Azure. So this is Linux machine 3, right? So if you want to cross check whether this Linux machine 1 is communicating with Linux machine 2 or not, sorry, Linux machine 3 or not, what we need to provide? Linux machine 1 private IP address, right? So ping 10.11.1.4, enter. So is it communicating? Otherwise, Linux machine 3 with Linux machine 1, ping 10.12.1.4. Is it communicating? Whether Linux machine 3 is not able to communicate with Linux machine 1, Linux machine 1 is not able to communicating with Linux machine 3. So got it? What is happening now? What is the conclusion? Any of you from this dashboard diagram? So the conclusion is, by default, there is a communication between virtual machines in a same virtual network, but we are unable to connect or communicate with the virtual machines of different virtual networks. This is the conclusion. Okay. So by default, there is a communication between virtual machines in a same virtual network, but we're unable to connect or we're unable to communicate with the virtual machines of different virtual networks. So if you observe this Linux machine 1 and Linux machine 2, they fall under same virtual network. That is the reason this communication is happening between Linux machine 1 and Linux machine 2. But it is not happening for whether it is a Linux machine 1 to Linux machine 3 or Linux machine 3 to Linux machine 1. It is not possible because the thing is they are falls under different virtual network. So that is the reason why this communication is not happening between these two Linux machines of two different virtual network. Okay. So now in order to overcome this limitation, in order to overcome this limitation, we are moving for VnetPeering concept. So now what is this VnetPeering? To establish the communication between virtual machines in different virtual networks. To establish the communication between virtual machines in different virtual networks. In our case, Linux machine 1 and Linux machine 3. So this is the reason why we are going for or why we are moving for VNet peering concept. So you have got this concept, right? What is the limitation and why we are going for this respective concept? Any doubts till now? No doubts, right? It's fine. So now let us implement this concept practically. Okay, so this VNet peering, so that we are able to communicate between this Linux machine 1 to Linux machine 3, Linux machine 3 to Linux machine 1, or Linux machine 3 to Linux machine 2, Linux machine 2 with Linux machine 3. So now go to this respective VNet. So you can go for any VNet. Okay, so whether you can go with some destination VNet or source hyphen VNet, you can go with any virtual network. Okay, so I'm going with source hyphen VNet. So here drawing option called as an peerings. Go to this peerings, click on add. So just I'm giving some source to destination. and here destination to source. So here where which virtual network you want to communicate, right? So this is already is a source hyphen VNet. So then you need to choose the destination hyphen VNet here. Okay. So whenever if you click on add, right, two peerings is going to create in both virtual networks. I mean source hyphen VNet as well as destination hyphen VNet. So at the same time, this peering concept is going to be created. So that is the reason you can go with any virtual network. Okay, click on add. If you observe, see here, successfully added VNet peering destination to source. That is nothing but destination hyphen VNet, and successfully added virtual network peering source to destination. That is source VNet. Destination to source is nothing but destination hyphen VNet. Source to destination is nothing but a source hyphen VNet here. And even you want, you can cross check as well. So if you observe, we're having some source to destination VNet, right? I mean peering concept is implemented. So you can go to destination hyphen VNet, go to this peerings here, destination to source. So maybe now it is communicating now. Here, this is Linux mission 3 and this is Linux mission 1. So once if you implemented or once if you implemented this VNet peering concept within the respective virtual networks, now we are able to communicate between Linux mission 1 to Linux mission 3, Linux mission 3 to Linux mission 1. Same way for Linux mission 2, Linux mission 2 and Linux mission 3 as well. Okay, so or even you can cross check this uh, Linux mission 2. So we need to give the Linux mission 2, which is need to provide the IP address of Linux mission. Ping 10.1.1. Here is communicating, right? So Linux mission 3 is communicating with Linux mission 2. In Linux mission 2, if you want, you can provide IP address of Linux mission 2. I mean private IP address. This is ping 10.7.0. Here now it is able to communicate between these two VMs. So this is VNet peering basically. So we need to implement the VNet peering concept virtual network. We need to implement the VNet peering concept at virtual networks or respective virtual network. This thing is so that we are able to do the communication between Linux version 1 and Linux version 3 and also Linux version 2. Okay. So any doubts, any of you? This is nothing but a VnetPeering concept. Fine.